the quadratic formula. So in this section, we're going to prove the quadratic formula, and we're going to try to apply it to some examples. To this end, let's try to recall this property. So if t and s are two real numbers, then the square of their sum is equal to the sum of their squares plus twice their product, right? So let us redo this work. So how do we find that this side and this side are equal? We're gonna FOIL this side, let's say. So let's FOIL t plus s squared. Well, t plus s squared is the same as t plus s times t plus s, right? And how do we FOIL such a thing? Each summand here is gonna talk to every summand here, right? So t times t is gonna be t squared, and t times s is gonna be ts, and s times t is gonna be st, and finally s times s is s squared, right? All right, and t times s and s times t are the same because multiplication is commutative, right? The order doesn't matter when you multiply. So this is the same thing. So this is 2 times ts, or 2 times st, and as such we get the right hand side of that pink equation above, right? So we get this. Moving on, let's do exercise 1. Show that for any triplet x, a, and b, real numbers, such that a is not 0, then this identity holds. Okay, and I hope you see why I'm requiring a not to be 0, because I'm dividing by a, and if a is 0, then I'm gonna get an undefined expression. Okay, this is why a must not be 0. All right, so how do we prove this equality? And I hope you do it, you stop the video and you actually do it yourself. It's not that hard in this case. You just have to expand, let's say, the left-hand side, right? The left-hand side being this, and hopefully terms are gonna cancel each other at the end of the day, and we're gonna get this. Okay, so let's expand the left-hand side. So we expand the left-hand side, and I'm gonna abbreviate or write the acronym for left-hand side by LHS, and we get, what? Well, let's copy it first. So x plus b over 2a squared minus b squared over 4a squared. This is the left-hand side, right? And let's expand it. How am I gonna expand this? I'm gonna expand this expression, right? This is the square of its sum, you see? I'm talking about this expression right there. This is the square of its sum. Well, either you do it again, but we just did it in the previous, or we just recalled it, let's say, right? So we just recalled it. I'm gonna inherit, or I'm gonna use that property that I just did before for this left expression, right? I'm gonna use it where t is x and where s is b over 2a, right? So let's give this guy a name. How about we call it star? So we're gonna use star now, right? We're gonna use star over here. So we're gonna use star with what? So the t over there is the x, and the s over there, by over there I mean in star, is b over 2a, right? So we get what? We get t squared. Let's actually zoom out to see both of them at the same time. So what do we get? we get t squared. What's t in our case? Is x. So x squared plus twice the product of t and s. The product of t and s, well, t is this much, and s is this much, b over 2a. So I get this, right? Plus the square of s. What's the square of s? It's the square of b over 2a. Am I correct? All right, so everything you see here is this guy. So let's highlight this fact. So everything you see here is this guy, right? And then I'm gonna chip away b squared over 4a squared. So minus b squared over 4a squared, correct? So the blue part is this part, minus this expression, b squared over 4a squared. All right. And this is equal to x squared plus 2 divided by 2, right? The whole thing here is I have multiplication here, right? So this is the same as saying 2xb divided by 2a. So this expression is 2xb divided by 2a, right? And 2 divided by 2 is 1. So what do we get? We get xb over a at the end of the day. Xb over a. All right, plus what? Plus this guy. Well, the square of a quotient is the quotient of the squares. So we get b squared over the square of 2a, which is 4a squared, correct? So b squared divided by 2a squared is, what's 2a? What's the square of 2a? Is 4a squared. All right, so this is still the blue part. This is still the blue part. Just to be very, very clear. Minus what you see over here, right? b squared over 4a squared. Make sense? All right. Very good. So keep an eye on what you wanna do. You wanna show that the left-hand side here in exercise 1 is equal to the right-hand side. We started by the left-hand side and we're expanding and trying to do now some simplification. Hopefully we get to this. I hope you see it. That's what should survive in some sense from this entire expression. So this part, because that's the right-hand side. But it's not clear to see that the last two parts, the last two expressions, I should say, they cancel each other because I have b squared over 4a squared minus b squared over 4a squared. So they cancel each other, right? And let's color this in a different color. How about green? So they knock each other's out, and you get x squared plus xb over a. And what's xb over a? Isn't it b over ax? Isn't it b over ax? So that's the same as x squared plus b over ax, right? Which is the right-hand side as desired. Which is the right-hand side. So this shows the validity of this identity for all choices of x, a, and b, as long as obviously a is not 0. Okay. All right. Next. Remember, we are doing a few exercises that are gonna lead us to show the quadratic formula. Okay. So all these exercises that you're gonna see, there are just a couple. They are my tools to actually show you the quadratic formula. All right, we still need these two things here. What does this pink thing say? If x and y are real numbers, then this product is the difference of the squares of the x and y that are involved in this left-hand side. Okay, let's do it. So x minus y times x plus y, let's FOIL it out, and we should get the right-hand side, right? Let's do that. So x minus y times x plus y. So remember, everyone here is going to talk to everyone here, right? X times x is x squared. X times the y with a positive sign here. So plus x times plus y is plus xy, right? And then minus y times x is minus yx. And then minus y times y, what's minus y times y is minus y squared, right? Okay. And now what can you say? xy and yx, I mean x times y is the same as y times x, correct? Because of the commutativity of multiplication. So these guys are the same, and since they have the different signs, they cancel each other out. So this and this cancel each other, and then what are we left with? X squared minus y squared, right? So we are left with x squared minus y squared. Okay. So we get this. I'm just recalling this part. All right. With this in mind, now we're gonna verify that this is exercise 2. If t, u, v are real numbers, so if I have 3 real numbers with the property that u is non-negative and v being non-zero, then this right-hand side, this left-hand side is gonna be this right-hand side. Okay. So why are we assuming u not to be zero, not to be negative? Because we're talking here about the square root of u, right? So certainly this has to be part of the discussion, right? Remember, square root of a negative number doesn't make sense, correct? And v, why are we asking that v not to be 0? Because I'm dividing by v as such. So these assumptions are going to tell me that each of the following expression is going to be meaningful. And what this identity is trying to tell me, that if you FOIL this out, you should get that guy, right? Okay. All right, so as we said, we're going to FOIL it out, but I mean, just look at the structure of this product. I have t minus something times t plus the same thing. I hope you see that this is structure-wise, this is reminiscent to this. This is of the form x minus y times x plus y, right? It's of this form. As such, I can, instead of reinventing the wheel, instead of foiling it out, I have the result at my disposal. I'm going to just use, okay? But I'm going to use it once I build the dictionary between the two. So t is going to be x, and the square root of u divided by 2v is going to be my y over here, right? So left-hand side of what? Left-hand side of this guy, right? So left-hand side of this guy, let me actually say indeed, just because we're showing it, right? So indeed, the left-hand side is this. That's the left-hand side, and we just made the case that the structure looks like the structure of the left-hand side of this previous identity, correct? Let's give it a name. How about asterisk? So we're gonna use asterisk. With the following choices: x being t and y being square root of u divided by 2v, right? This is what we said. If you see x as t and y as the square root of u over v over here, that left-hand side is exactly this left-hand side. All right, so instead of doing all this work in purple, I can just use the result of asterisk. So what does asterisk say? It says it's the difference between the squares of x and y. So it's the difference between x squared, which is t squared in this case, and the square of y, right? The square of y, you see asterisk, the square of y, and the square of y is the square of this quotient. So it's going to be the square of this quotient. Square root of u over 2v, right? Makes sense? One more time. What did we do here? The left-hand side of this is, the structure of this is the same as the structure of the left-hand side of equation asterisk. If you build a dictionary that x is t and y is the square root of u over 2v, then this and this are exactly the same. I'm applying asterisk the result instead of reinventing the wheel, instead of redoing the work. I'm applying the result. It's the difference between the corresponding squares. So x squares, which means t squares, and y squared, which means that guy squared, right? Okay, so what are we promised to get? We promised to get this piece, correct? Okay, so this is equal to t squared minus the square of a quotient is the quotient of the squares, right? What's square root of u squared? Let me write it. Square root of u squared divided by the square of 2v, correct? Okay, what's the square root of u squared? Square root of u squared is u, right? Square root of u squared is u. So you get u divided by 4v squared. Am I correct? Because 2v times itself, 2 times 2 is 4, v times v is v squared. Am I correct? Okay. And this is what? This is exactly the right-hand side. This is exactly the right-hand side. So that's exactly the right-hand side as desired. All right, so exercise 2 now is at our disposal whenever we need it. Okay. So now we're ready to prove the quadratic formula, and let's give ourselves a setting, and here we go. Assume that a, b, and c are real numbers with the property that a is not 0. So a is not 0, and this expression b squared minus 4 times ac, this expression is at least 0, so this expression is non-negative. Further, suppose that we want to factor the second degree polynomial. This is a polynomial of degree 2, right? So suppose we want to factor this. What does factor mean again? Factor means we want to write this as a product of things, right? This is a sum of things. We want to write it as a product of things. So that's the idea. That's the idea. This is what factoring means, right? So I want to factor this sum of three entities. All right, let's start. So let's start. Let me zoom in a little bit. It's too much. Okay, this is okay. So ax squared plus bx plus c. Since a is not 0, remember a is not 0, let's factor out a. Let's factor out a. If you factor out a, you get a times, by factoring out a means every one is going to be divided by a, right? If you factor out a here, you get this guy over a, which means x squared, correct? And this, if you factor out a here, you are gonna get b over a x, correct? Because you're dividing this term by a. Factoring a out means you're dividing that guy by a, right? This divided by a is b over ax. Make sense? Plus c over a. All right, to see it better, if you will, distribute the multiplication over addition. A times x squared is ax squared plus a times b over ax. What's a times b over ax? A and a cancel each other. You get bx. That's the middle term. And lastly, a times c over a with a plus sign. So a times c over a is c times a divided by a, which means c. Correct? So going backwards probably makes it easier to digest. All right, and then what I want to do is I want to focus on this guy. You see this guy? Let me take you to an earlier result. So that guy that I boxed in blue downstairs or below, that's this guy, right? That's this guy. And we just showed in exercise 1, we showed that this guy, the right-hand side, is equal to this left-hand side. Make sense? Where, I mean, as long as a is not 0, but our a, in the discussion below, is not 0. So that guy is exactly this guy. So I'm going to copy this and replace this guy by that guy, right? So what I'm going to get is, how about we copy it? So that guy is going to be needed to replace this blue part, correct? We're going to get this. So that's what? That's the blue part, right? This is the same as the blue part that you see right above. And let's preserve the rest. So that's going to be equal to a times the blue plus c over a, right? Okay. All right. And then allow me to now erase those blue things. Okay. And then what do I have? How about we combine the last two quotients by making the same denominator here. And what's the same denominator between 4a squared and a? How about 4a squared, right? That guy would be the same denominator between 4a squared and a. So we're gonna rewrite a as 4a squared. That's the idea, right? So we get a times that guy x plus b over 2a squared minus b squared over 4a squared. Again, as we said, we want to rewrite this as something over 4a squared. Why? Because I would like to combine these last two. You're going to see why. Okay, so what is the thing that should be the numerator of this so that this quotient, the value of this quotient remains c over a. So how did I go from a to 4a squared? I multiplied downstairs by 4a, right? So I multiply this guy by 4a. And if you multiply downstairs by 4a, you gotta also multiply upstairs by 4a. Agree with me? Why? Because the value now, the new representation of this quotient, which is 4ac over 4a squared, it's a new representation, but the value is the same. The value of this is still c over a, right? You can still simplify by the 4a we just multiplied with. So you get c over a. The value is the same, but now it looks different. Okay. Now I have the same denominator between the last two. How about we condense them? How about we condense the two, and what do we get? We get a times, so let's keep the first part as is, b over 2a squared minus 4a squared as a numerator downstairs, and b squared minus 4ac. Agree with me? Okay. Why did I have minus here? Because look, this minus is for the entire numerator, correct? And what I should get is negative b squared plus 4ac. Well, this minus is for the entire numerator. That's exactly what I just said. Minus b squared, and then minus times the minus is the plus 4ac, right? So these are the same once you glue them together. All right. And now I want to ask you to focus on this entire factor here, except for the a. I'm talking about everything else. So the structure here looks like t squared if you think about this whole thing as t squared minus, let's talk about this whole thing as u, and downstairs 4a squared. So this looks like everything, I'm talking about everything between the parentheses, the big parentheses. So technically everything except a in the last expression. That thing can be thought of as the square of something. Let's call this thing t. And this thing can be thought of as u. Everything upstairs is labeled as u divided by 4a squared, right? So the structure now looks like t squared minus u over 4a squared. T squared minus u over 4a squared. Keep this in mind. T squared minus u over 4a squared, right there. You see this? T squared minus u over 4a squared. Okay, v squared, a and v being the same. T squared minus u over 4a squared. That's the structure. You get this. You can split it as such, right? Makes sense? So what I'm gonna do is instead of this whole thing, I'm gonna write it this way. So it's t minus the square root of u over 2v times t plus the square root of u over 2v. So let's use exercise 2 then, the result of exercise 2. So one more time, we're gonna use exercise 2 with, as we said, the t of exercise 2 is gonna be x plus b over 2a. The u in exercise 2 is gonna be b squared minus 4ac. And the v in exercise 2 is gonna be our a, right? The v of exercise 2 is gonna be our a. And by the way, I forgot to mention, I can use exercise 2 as long as u is non-negative, right? Because I need to talk about square root of u. So as long as u is non-negative. And what's our u here? What's our u here? B squared minus 4ac. And what am I assuming on, what's my assumption on b squared minus 4ac? Remember this? B squared minus 4ac is non-negative, right? So this guy is non-negative. So I can use it as the u in exercise 2. And the v here is supposed not to be 0. And who's playing the role of v? It's the a. And what do we know about a in our discussion? It's not 0. So all the conditions of exercise 2 are verified. And as such, I can employ it with my choices of t, u, and v, right? All right, and what does it tell me? Exercise 2, what does it tell me? Well, it tells me that, let's keep the a, it tells me that I can write this whole thing as t, which is x plus b over 2a, minus, if you remember, minus the square root of u, which is b squared minus 4ac. All right, let me extend this umbrella here, right? Divided by 2v, right? At the time, let me take you back. Divide by 2v, remember? Okay, and then the next factor is going to be the same, but with a plus sign. Okay. So divide by 2v. And as we said, the next one is going to be the same, but with a plus sign. So I'm going to just copy it. This is the t part plus the square root of b squared minus 4ac divided by 2v, right? This whole thing like this. Okay. All right, makes sense? Sorry, I meant to write, obviously I meant to write a because there's no v in our discussion here, it's a. So it's a, we get this, right? Okay, and then how about, since these two guys have the same denominator, how about combining them? Let's combine them. So we get, this is then equal to a times, since they have the same denominator, which is 2a, upstairs I get b minus the square root of b squared minus 4ac, divide by the 2a. And similarly here, but now I'm gonna have b plus over here, right, because of this plus. So times x plus b plus the square root of b squared minus 4ac, divide by 2a. Makes sense? All right, and one last step. Look, I'm gonna rewrite now. You see this plus here? I'm gonna divide it into two minuses in the following sense. I can write plus as subtracting. I mean, if you add something to another thing, it's the same as subtracting the opposite of the thing, right? The opposite of the thing. So the opposite of the thing, and obviously here I should have parentheses, b squared minus 4ac over 2a. This is this factor. What did I do here? Well, technically, this is what I did. Let me isolate this concept for you. What I did is, if you have x minus y, or sorry, x plus y, that's the same thing as x minus the negative y, right? That's exactly what I did here. Do you agree with me? So instead, I mean, if you add something to another thing, it's the same as if you subtract the opposite of that thing, right? That's the same as x plus y. Okay, so I used y to be this whole quotient here, so I can regard this as x minus the minus y, right? And I'm gonna apply the same way over here, and I'm gonna get x minus the negative b plus square root of b squared minus 4ac over 2a, right? So I'm gonna have two parentheses. Make sense? And then what? The last step is that minus that you see over here is either for the entire numerator or for the entire denominator, right? Let's take it to the numerator. So the minus is gonna go upstairs, and I'm gonna get, move a little bit here. So a times, as we said, let's take it upstairs. So I get x minus. So what's the thing I'm taking upstairs? That minus here, this minus, the second one. Bring it upstairs, minus the b, and minus times that minus is going to turn this into a plus. So we get minus b plus the square root of b squared minus 4ac, divide by 2a, right? And similarly here, this minus over there times b is minus b, and this minus over times the plus is going to be minus the square root. So the right factor is going to be x minus the negative b minus the square root of b squared minus 4ac. Oops. Right? And then the whole thing is divided by 2a over here. Right? So we get this. And now let's look at what we wanted and where we are. The discussion was about, under these conditions, I wanted to factor the second degree polynomial ax2 plus bx plus c. So the ax2 plus bx plus c, we manipulated this expression all the way to here. And now look at this. This is a product of three factors. The first factor is a. The second factor is this giant thing here, x minus this quotient, times the third factor is this guy, x minus this quotient. As ugly as it looks, that's good news, because I rewrote this expression, the sum, as a product. And this is the idea of factoring. This is what I wanted to do. I wanted to factor, right? I mean, it looks complicated, but I mean, the formula this endpoint looks complicated, but we're gonna appreciate it in application, right? And this is the proof of it. You don't need to know the proof. This is the proof of it, but you don't need to know it. It's just there just in case you wonder why the formula is the way it is, okay? Or how did people think about it? Anyway, so let's record it, and let's refer to it as the quadratic formula. Here are the details. Let a, b, c be real numbers such that a is not 0 and b squared minus 4ac non-negative. Remember, these assumptions are necessities, right? Because at the end of the day, we needed to divide by a, right? Remember, it's right there. It's right there, right? We needed to divide by a, and we needed b squared minus 4ac to be non-negative, so that they can be the radicand, correct? So in this discussion that you see, this guy is gonna be called as p, and this guy is gonna be called as m in the formulation of the theorem. All right, I called it p because, I mean, p and m resemble each other. The only difference is that in p I have a plus sign, and hence the p positive, and this quotient I have a minus, and hence the name m, or the label m. Okay, and realize that p and m have to do with the ABC given, right? They are the recipes of P and M only involve A, B, and C, right? The A, B, and C given in the discussion, right? So P and M are known once you know what A and B and C are. All right, anyway, so back to this. So under the assumptions that we just talked about, a, b, c be real numbers, a not 0 and b squared minus 4ac being non-negative, then the second degree polynomial factors as such, right? This is exactly what we proved above. This is just recording the result. Ax squared plus bx plus c is equal to a times x minus m times x minus p, where m is this and p is that, right? So it's a times x minus p times x minus m, but x minus p times x minus m is the same as x minus m times x minus p, as we said in the formula, right? All right, so this boxed result is the quadratic formula. Okay, and what's the essence of this formula? It allows us to factor. A second degree polynomial as long as a, what's a? The coefficient of x squared is not 0. Well, it's not 0, and hence the name, right? Second degree polynomial. If a is 0, then this whole term vanishes. So it's not a second degree anymore. It's a first degree at best. And b squared minus 4ac being non-negative, for this to make sense as well, right? Under these two hypotheses, I can apply the quadratic formula. If one of them fails, the quadratic formula doesn't apply anymore, right? All right, let's put the quadratic formula in action. Let's do the following exercise. Factor each of the following three polynomials, or second degree polynomials. Part 1, 3x squared minus 2x minus 2. Let's start with this. So part 1, 3x squared minus 2x minus 2. I want to factor it, right? And this is a second degree polynomial, so I want to use the quadratic formula, the one that we just boxed above. All right, who would be the choice of a? Who's my a in my discussion, or in the quadratic formula? Who's my a in our context? Well, a is the coefficient of x squared, and the coefficient of x squared is 3, right? So a is So A is 3. Who's the B? Well, the B is, look here, the coefficient of x is the B as long as the sign is positive, as long as this sign is plus. Well, here I have a negative, right? So I cannot yet see who B is. I should have a plus. Well, to have a plus here, the minus is going to be absorbed by 2. Make sense? So now the structure looks like plus some number times x, plus some number times x. And what's that number, which is b? What's that number in my context? -2, right? And lastly, c is the constant part. And the constant part, I call it c as long as I have a plus here. Well, I have a negative here, so who's the constant part? Yes, it's -2. Again, if you want to see it even better, that's the idea, right? Plus the constant part. So that constant part better be -2, so that the plus that constant becomes -2. So C is -2. Correct? All right, so I'm gonna use the quadratic formula with these choices, right? With these choices, A, B, and C. All right. One more thing. I should have waited before I labeled it. But anyway, to actually apply it, I still need that b squared minus 4ac being non-negative. A is not 0, certainly, because A is 3, right? A is 3 in my context. I know this. It's right there. I still have to verify that b squared minus 4ac is non-negative. By the way, b squared minus 4ac has a special name. It's called the discriminant of the polynomial. This is called the discriminant of the polynomial. Okay? Anyway, I'm not going to write it, but record this if you will. B squared minus 4ac is called the discriminant of the polynomial. I still need to verify that this guy is non-negative. What's b squared minus 4ac? Well, it's the square of b, and who's my b? -2. Minus 4 times a, who's a? 3 times c, and who's c? Is -2. Correct? One more time. I'm trying to verify, because to apply the quadratic formula, I would like b squared minus 4ac not to be negative. So I'm testing, I'm checking that. B squared minus 4ac is the square of my b, so it's the square of -2, minus 4 times a, so 3, times the c, which is -2. Okay. All right, let's check that. What's -2 squared? -2 times -2 is 4. And what's that? Minus, what's 4 times 3? 12. 12 times -2 is -24. -24 times this negative is +24. So +24, and the sum is 28, which is certainly non-negative. So as such, I checked this. I checked that. This is checked now. Then, because of the quadratic formula, I can now proceed. Then I can factor, and the factorization happens once I find the m and once I find the p, and I just rewrite this, right? So I want to find m, I want to find p. Okay, so what's m? M is equal to, it's right there on the screen, right? Minus b, so the quotient, minus b minus square root of b squared minus 4ac divided by 2a, right? Okay. Well, I mean, I just copied now. So, well, b is -2. So negative b is negative the -2. So negative b is negative the -2. So negative the -2 minus the square root of b squared minus 4ac. What's b squared minus 4ac? We just found b squared minus 4ac. It's 28. So this guy is going to be 28 then. Divide by twice the a. twice the a. And who's our a? Is 3. So twice the 3. Yes? All right, let's try to simplify if we can. Okay, so this is the same thing as negative the negative 2 is 2. And square root of 28 is what? Well, square root of 28, what's the prime factorization of 28? Well, the prime factorization of 28 is 2 squared times 7, right? 28 is 4 times 7, right? And divide by 2 times 3, which is 6. All right. Square root of 2 squared times 7, square root commutes with multiplication in the sense that square root of a product is the product of the square roots. So we get square root of 2 to power 2, which is square root of 4 times square root of 7. And square root of 2 is, square root of 4 is 2, right? So it's 2 minus 2 square root of 7 divided by 6. Agree with me? One more time. Square root of 4 times 7 is square root of 4, which is 2, times square root of 7, which is square root of 7. So we get that. And now if you factor out a 2 upstairs, you get 1 minus square root of 7. And downstairs you have 6, right? I factored out a 2 just to simplify the quotient. I mean, I'm factoring because I realized that I have a common divisor upstairs and downstairs. 2 is a divisor for the guy upstairs. I'm showing it to you. You can see it. 2 times that guy is the numerator. Divide by 6. Certainly 6 is a multiple of 2. It's an even number. So as such, I can simplify by 2. And if you simplify by 2, we obtain 1 minus square root of 7 over 3. Okay, so who's that guy? That's the m guy. Okay, so do I need m? Yes, I need m because that's the guy who sits here in the factored form of the second degree polynomial, right? So that's the guy that sits here. So I know this guy now. I'm still after p. By the way, a, I know a. A is 3 in my discussion. So I have this guy times x, which is the variable, right? Minus the m. We just found m. And we're still missing the p. And p is this guy, right? How is p related to m? The only difference between p and m is that this minus in m turns into a plus in p. That's the only difference. They're like cousins, right? Funny cousins or something. All right, so this minus here turns into a plus, and that's the relationship. That's the only thing that I need to tweak in m to get p. So that's the sign I'm talking about. If you switch this sign to plus, you obtain p. Let's keep track of this minus actually. How about we highlight it in red? This minus, that's gonna turn into a plus to get our p, right? That's this minus, which is this minus, which is this minus, which is that minus, and hence that's the same minus, right? So what's p then? You tweak this to a plus, and that's the same minus all the way. So the same thing is gonna be here. You're gonna tweak that guy to a plus to get the p. So p is gonna be 1 plus square root of 7 over 3. Make sense? So p, which is very similar to m, but the only thing that changes is this sign is gonna turn into a plus, and we kept track of that sign. It's this sign, and we tweak all these red parts. We turn them into pluses, and then the final thing is gonna be 1 plus square root of 7 over 3. That's gonna be the p. Why am I doing this? Because I have a blueprint for m. I have a blueprint to actually find p. Why do I have to go through all of this? Since it's the same process. So I'm gonna just tweak the appropriate thing and keep track of what I tweaked and see the actual result. So p. So and p is. I'm gonna put dot dot dot. And p is, in our context, is 1 plus the square root of 7 over 3. Okay. All right, so I found all the ingredients. I found all the ingredients in the factored form. So now I can just simply write a times x minus m times the quantity x minus b. So it follows that. So it follows that. Our second degree polynomial, which was 3x squared minus 2x minus 2, can be factored as, again, I'm applying the quadratic formula. I'm just applying this result. A, who's my A? My A is 3 in this context, right? It's labeled somewhere here. It's right there. So my A is 3, so it's 3 times x minus the m. And who's the m? Is 1 minus square root of 7 over 3. Times x minus the p. And who's the p? It's this guy, correct? So let me make some room. Let me make some room for p. So I get what? I get 1 plus square root of 7 over 3. Okay. So that's the factored form of 3x squared minus 2x minus 2, right? So what you see on the right side is the factored form of 3x squared minus 2x minus 2. Okay, factored in the sense that it's written as a product of things, and we're gonna see later why writing it as a product of things is more convenient. Okay, but as of now, let's just enjoy the factorization part. So this guy factors as such because it can be written as a product of 3 entities in this case. 1, 2, 3. Okay, all right. So this is part 1 of this exercise. Part 2, we want to factor now minus x squared plus 3x plus 1. So part 2, let's change colors. Part 2 is we want to factor minus x squared plus 3x plus 1. Okay. By the way, I mean, why not just doing it one time? How about you actually, on your own, try to foil that right-hand side, okay? I mean, try to foil the right-hand side. I mean, for sure you're gonna get the left-hand side, but at least you kind of like see the transition. And what you're gonna see in the process is exactly what we went through over here. What we went through over here in this discussion, okay? Obviously here they were hidden by B's and A, but that's, trust me, this is exactly what you're gonna be seeing. You're gonna technically going backward, right? You're going from the product to the sum. So you're transitioning from this last equation expression to the first expression. You're gonna go backwards in some sense. Okay. All right, just do it once just to see, to kind of believe it even more, but it's certainly correct. All right, so let's factor this guy. So who's the A? By A, I mean, obviously, in the quadratic formula, it's the coefficient of x squared, and the coefficient here is -1, right? Because negative x squared means -1 times x squared, right? So who's the A? It's -1. Who's the B? It's 3, because B in the quadratic is the coefficient of x, as long as the sign is plus here, right? That's the B. And the C part is, the constant part is, of the quadratic formula is that guy 1, because I have already a plus. So plus C, so C is 1. So C is 1. And B squared minus 4AC, the discriminant is the square of B, so the square of -3, minus 4 times the A. And what's the A? The A is -1. The a is -1, and the c is 1. So it's like this. And this is how much? This is 9. -3 squared is 9. And this is +4, right? This whole thing is +4. Correct? Because -4 times -1 is +4 times 1 is +4. So this whole thing is 13 then. And 13 is certainly bigger than or equal to 0. So the conditions of the quadratic formula are verified, right? Namely these two guys. They are verified. As such, I can apply it. So I can apply the quadratic formula because the requirements to use it are checked. Okay, so then I'm gonna write, we're gonna use the quadratic formula with the following choices of A, B, and C. Okay. All right. So as such, I'm gonna be able to find the m in the discussion and the formula. And what was m? It was the quotient of -b minus square root of b squared minus 4ac. This is the recipe, right? This is the recipe of n divided by 2a. Okay. And in this context, -b is negative, right? -b is -3 minus the square root of the discriminant. And what's the discriminant here? B squared minus 4ac. What is it? It's 13, right? It's 13. Divide by twice times a, and a is -1. A is -1. So twice a is 2 times -1. Okay, so this is the same then as -3 minus square root of 13 divided by -2. Makes sense? And now if you simplify by -1, okay, in order to see why simplifying by -1 can take place, how about we factor out -1 upstairs? How about we factor out -1 upstairs? We get -1 times 3 plus square root of 13 divided by -2. Am I correct? And -2 is the same as -1 times 2, yes? So that's the same as -1 times 2. Okay. All right. And now hopefully you see that this and this can cancel, the -1 and the -1. And as such, we obtain 3 plus square root of 13 over 2. Oops. Over 2. Makes sense? All right. That's the m guy. That's the m guy. Where do I need m? It's the guy that sits here. That's the m guy. How about the p guy? The p is very much the same as we talked about. Very much the same as m, but the only sign is this guy, right? Instead of minus is gonna be plus. Okay. So p is P is -b plus square root of b squared minus 4ac divided by 2a. This is for any context. In this context, b is 3 and b squared minus 4ac is 13. So I'm gonna rewrite this whole thing, but instead of this minus, I'm gonna have a plus, right? And instead of this minus, I'm gonna have a plus. So I'm gonna get -3 plus square root of 13 divided by -2, right? So I jumped immediately to the stage because I understand that the only difference between m and p is that this sign is gonna be a plus. So I just copied it. You can stop here, or if you want, how about we still factor out a -1 and play the same game as above. And if you do so, you're gonna get -1 upstairs, 3 minus square root of 13, and the whole thing is divided by -2, and -2 is -1 times 2. I'm playing the same game. All right, now -1 divided by -1 is still 1, and hence I obtain something which I anticipated it. which is just that sign is going to be changed, correct? That's exactly what happened. All right, so at the end of the day, so thus our second degree polynomial, which was negative x squared plus 3x plus 1, can factor as, where is it? It's right there. Can factor as a, who's our a in our context? Negative 1 times x minus m times x minus b. So a, what's a? Negative 1, right? So negative 1 times x minus m, and who's m? This is m, 3 plus square root of 13 over 2, times x minus p, and who's p? Is 3 minus square root of 13 over 2, right? Okay, so I just factored it then. Right? Let's move on to the last second degree polynomial that I still need to factor, 2x2 minus x minus 2. Okay, 2x2 minus 2x minus 2. So part 3, 2x2 minus x minus 2. All right, so one more time. Who's a? The coefficient of x squared is 2 in my case. The coefficient of x squared is 2. b, which is the coefficient of x. Well, the coefficient of x is negative 1, right? So why it's negative 1? Because I should see this as a plus sign, and as such this must be a negative 1, correct? Minus x is the same as adding negative 1 times x, so b is going to be the coefficient of x, which is negative 1 then, and c is going to be negative 2 for the same reason, right? C is going to be negative 2 because in order to see plus c, I'm going to have plus negative 2. Agree with that? All right. How about the discriminant in our case, which is b squared minus 4ac? What's b squared minus 4ac? It's the square of b minus 4 times a times, which is 2, which is times c, which is negative 2. Okay. And that's what? That's negative 1 squared is 1. And what's that? 4 times 2 is 8 times negative 2 is negative 16. So this whole thing is negative 16 times the negative that existed here is a plus 16. And this sum is 17, which is certainly non-negative. And as such, the quadratic formula is applicable. You can apply it, right? All right, let's just say it then. So we use the quadratic formula, QF for quadratic formula, with these choices. Okay. And then the only thing that's missing, again, I'm doing it slightly quicker because we've done a couple of examples similar to this. M is one of the guys, right? Remember, one of the guys, it's minus b minus square root of b squared minus 4ac divided by 2a, and a is 2 in our context. A is 2 in our context. Actually, before let me just keep it a for the moment. I'm just copying technically the formula at this point. So minus b is minus the minus 1 minus the square root of our discriminant b squared minus 4ac, and our discriminant is 17. The whole thing is divided by twice a. And whose a is 2. So that's going to be 2 times 2. All right. What's negative the negative 1? What's the opposite of the opposite? Is itself, right? The opposite of something is itself. Minus square root of 17 divided by 2 times 2, which is 4. And remember the funny cousin p is very similar to m, but the only difference is that this guy is a minus sign, right? As a plus sign. So the only difference is that this guy is a plus sign and that guy is the same as this guy, and this guy is the same as this guy. So if you tweak this to a plus, you're going to tweak this to a plus, and ultimately you're going to tweak this to a plus, and hence the quotient P is going to be 1 plus square root of 17 divided by 4, right? Okay, so these are M and P, and therefore the quadratic formula yields that our second degree polynomial 2x squared minus x minus 2 can be rewritten as a, which is 2, times x minus m, and who's m? 1 minus square root of 17 over 4, times x minus the p, and the p is 1 plus the square root of 17 over 4. Agree on that? So we factored the second degree polynomial, and the factored form is this. All right? Very good. Let's move on to the next topic. Let's see this property, the zero factor property. What does it say? It says, if you have two entities, two real numbers, then the following are equivalent. The product of A and B is 0. That happens precisely if either A is 0 or B is 0, right? Or both. I mean, this is not news to us. I mean, we know this. A product of two entities is 0. That happens precisely when at least one of the two factors is 0, right? At least one. I mean, potentially two, maybe, but at least one of them is 0. And this is exactly this property. This is the zero factor property. Okay, let's take an example. Solve 2x plus 5 times x plus 4 equals 0. So solve this product being 0. Well, the zero factor property is certainly going to be involved in this game. Why? Because I have a product of two things to equal 0. And the product of 0 happens precisely when one of its factors is going to be 0. So what are the factors here? 2x plus 5 and x plus 4, right? So by the zero factor property, this is going to be equivalent to either the 2x plus 5 is the 0 who's making the product to be 0, or the x plus 4 is the guy who's making the product 0. So at least one of them, right? So one more time. The structure of this equation is product of two things equals 0, and the product of two things is 0. That happens precisely when one of the factors, at least one of the factors, is 0. Okay, I hope you understand the meaning of this or. This is not the regular, the daily, the or that we use in our daily language. This or is inclusive. It's an inclusive or in the sense that if A is 0 or B is 0 or both are 0, that's going to happen, right? And it's an if and only if statement. Correct? Certainly if both of them are 0, the product is 0. No problem with this. Okay? All right, so such an or is called inclusive or. Anyway, so we are here, right? Either this guy is 0 or this guy is 0. All right, now we solve for x, and solving for x amounts to writing what? 2x is equal to negative 5 in the first equation. And the second one becomes x equals negative 4, right? And that's exactly the same as saying 2x is negative 5 means x is negative 5 over 2. And the second one is simply x equals negative 4, right? So this product is 0 then exactly if x is negative 5 over 2 or x is negative 4. So what's the solution set then? The solution set is, remember, solution set means the set consisting of all solutions, right? So the solution set is the set in this context is the set consisting of our solutions. What are our solutions? They are -5/2 and -4, right? So this is the solution set of this equation. All right, next. Solve each of the following quadratic equations. Quadratic equation is an equation that can be written or in the form, one side is 0, the other side is a second degree polynomial. So it equates a second degree polynomial and 0. Okay? Any equation that can be written in this fashion is referred to as quadratic equation. And to be more precise, it's referred to as a quadratic equation written in standard form. So, because you can shuffle things around, right? Standard form means one side is second degree polynomial, the other side is 0. Anyway, so the question is to solve each of the following quadratic equations. Well, look at each one. Let's focus on the first for a second. I want to find where this second degree polynomial is 0. Well, I don't know how to do it except if I factor out this left-hand side. Once I factor out this left-hand side, I can invoke the 0 factor property, because once you factor it, it means that you are writing it as a product, right? And then you would be equating a product with 0. And if a product is 0, I know exactly what it takes. It takes that at least one of the factors is 0, right? But the 0 factor property just discussed. Make sense? So so if I manage to factor the left-hand side, the second degree polynomial, I'm gonna be able to use the 0 factor property, which is gonna take me to the promised land, right? In the sense it's gonna give me the solutions, right? Because it's pretty hard to just deal with it as is. It's a sum of things. It's a sum of things equals 0. I mean, it's hard to know when a sum is 0, because one of them can be negative, the other can be positive, right? It's pretty hard to actually find when a sum is 0. When a sum of numbers, I mean, real numbers is 0. So, however, it's pretty easy to know when a product of numbers is 0. It's exactly one of the factors is 0. Okay, so the idea is I want to transition the left-hand side to a product. Well, what's the tool? How do I factor out this second degree polynomial? Quadratic formula. We've talked about it, right? And in fact, we've talked about every single left-hand side in all these three equations. 3x squared minus 2x minus 2. We've already factored that out in the previous example. Let me take you there. It's this one, the green part, right? The 3x squared minus 2x minus 2, we knew that we can factor it as such. So I'm going to take this. Since we've done the work. How about we copy it and paste it right there. So that's the left-hand side, right? So part 1 would be, which is 3x squared minus 2x minus 2 equals 0. By the previous exercise, so let me label this as previous exercise. So previous exercise part 1, to be even more precise. So by that part, right, let's paste that. Oops, pasted it here, so oops. We take it all the way here, right? That guy is the left-hand side. So, and this is equal to 0. Why? Because that guy, I wanted to see when that guy is 0. Well, the left-hand side is exactly this product. So if you wanted this to be 0, then you're asking for this to be 0, right? All right. And now the 0 factor property kicks in. And what does it tell me? It tells me that at least one of these factors is 0, but 3 is not 0, right? 3 is a pure constant, so 3 is not 0. So it's either this guy who's making the product 0 or this guy who's making the product 0. So you can say then x minus 1 minus square root of 7 over 3 is the 0 guy, or x minus 1 plus square root of 7 over 3 equals, that's the 0 guy, or both, right? And this is the same as saying either x is 1 minus square root of 7 over 3, correct? Because here we had minus this guy equals 0. So x minus something equals 0 means x is equal to the thing, right? Or x is equal to 1 plus square root of 7 over 3. Okay? X equals 1 plus square root of 7 over 3. These are the P and M. These are the, okay, M and P respectively. The guys that we found in the quadratic formula. These are the guys that solve the problem actually. Okay? So the solution set in this context is simply consisting of this number and this number, right? So let me make some room here. Let me make some room. Just shift this a little up. Okay, let me shift this here. So the solution set is simply the set consisting of those two guys, the M and the P. So 1 minus square root of 7 over 3 and 1 plus square root of 7 over 3. All right, so these are the guys that once I replace x over here and over here by any of these two entities, I'm gonna get this left-hand side equals 0. Make sense? For part 2 now, negative x squared plus 3x plus 1, as I told you, we've done all of these before. Negative x2 plus 3x plus 1 is the second part in the previous exercise. It's right there, right? This is the factored form. That's the factored form. So if you would like this to be 0, right, this is the question, the current question, you want this to be 0, that's the same as saying that you want this product to be 0, which means you want x to be 3 plus square root of 13 over 2, or x to be 3 minus square root of 13 over 2. These are the P and M guys, right? Those guys. Correct? So I'll let you finish this on your own. Part 2. So please complete this on your own. I mean, it's the same thing as part 1. You just have to complete the details. Part 3. 2x squared minus x minus 2 equals 0, and we know how to factor 2x squared minus 2x minus 2. It's technically this guy. And if you want this guy to be 0, this means that you want the product to be 0. And this product has three factors, 2, x minus this guy and x minus this guy, right? X minus the M of the context times x minus the P of the context. Well, a product is 0 if and only if one of the factors is 0. Well, 2 is not the guy who's making the product 0, because 2 is is a pure constant, right? And it's a non-zero constant. So it's not the 2 who's making the product 0. It's actually either x minus the M or x minus the P. Correct? And as such, you get x equals M or x equals P, right? Okay. I don't know if I should write one of them. Okay, you know what? Let me just do one of them. And I'll leave the third one as an exercise. Okay, so let me just take all of this, shift it up, and shift the whole thing up. Oops. Put it here. Okay. All right, let's do the second one, say. So as we said, or you know what, I'll do the third. I'll leave the second for you. So the second is left as an exercise. on the third one, which is I want to match 2x squared minus x minus 2 to 0, right? So I want to match 2x squared minus x minus 2 equals 0, and as we said, 2x squared minus x minus 2 can be written in this format, with the, as this product, I should say. Let me take this and copy it. So 2x squared minus x minus 0, that's the same thing by the previous exercise as what? As this guy equals 0, right? So let me change this color to this. So that's going to be equal to 0, right? These are the same thing by the previous exercise. So by previous exercise part 3. Correct? All right. And then, as we were saying, this product is 0 if and only if one of the factors is 0, either the 2 is 0 or the x minus 1 minus square root of 17 over 4 is 0, or the x minus the 1 plus the square root of 17 over 4 is the 0, right? But the first one, this factor, which is a pure constant, this can never be 0, right? This is a pure constant and you're matching it to a different constant that can never happen for any x. No matter what x is, this can never happen, right? So the whole thing is just this product then is 0 if and only if the last two factors, one of them is 0, at least one of them. And this means that x is this guy or x is that guy, right? So that's then the same thing as saying that x is 1 minus square root of 17 over 4, or x is 1 plus square root of 17 over 4. Okay, so if you replace x by any of these two in here, that's the same x, right? If you replace this x by any of these two, you get that this expression is 0 actually. So solution set is just the doubleton, the set consisting of just these two guys. 1 minus square root of 17 over 4, over 4, and 1 plus square root of 17 over 4. All right, let's keep going. Exercise: let a and b be real numbers such that b is non-negative. So I'm talking about b being 0 or more, and it should be clear because I'm talking about the umbrella b, square root of b, and certainly b cannot be negative, so that this becomes a meaningful thing, right? All right, we want to multiply, and this is not what I meant. I wanted to multiply these two. Okay, I wanted to multiply a minus square root of b times a plus square root of b. Okay, well, the structure of this, does it remind you of any other structure? This is of the form x minus y times x plus y. This is the second part that we recalled, I guess, over here. What is it? It's right there. It's what we refer to as asterisk, right? It's what we refer to as asterisk. So it's of the form x minus y times x plus y, and we took the time to actually develop this formula. This is x squared minus y squared, right? So this was on page 2. All right, so I'm going to refer to it now. Where are we? We're here. Okay, so the question is to multiply. So this guy a minus square root of b times a plus square root of b is equal to by, so we're gonna use asterisk on page 2, right? Just go to page 2 with x over there being our current a and y over there being our square root of b, right? That's what I'm gonna be using. All right, and if we do so, we get what? It tells us it's x squared minus y squared, so it's a squared in our context minus b squared, y squared, and y squared is the square of square root of b, right? So one more time, that asterisk on page 2 tells us that x minus y times x plus y is x squared minus y squared, and x in our context is a, so it's going to be a squared as x squared, and y squared becomes the square of the square root of b. Okay, now what is this? What is this? A squared minus, what's the square of the square root of b? What's the square of the square root of b? That's b, right? That's b. Okay. And then the question is, solve the equation a squared minus b. By the way, I can't solve this using quadratic formula, but I'm gonna do it in a different way using I'm gonna observe what I've done in part 1 to solve this. But I encourage you actually to do it using the quadratic formula to get the same result. Okay. So we wanna solve a squared equals b. Well, that's the same thing as a squared minus b equals 0, right? That's the same thing as a squared minus b equals 0. And in part 1, what did we just found? What did we just find? That a squared minus b is equal to this product. Correct? So I can replace a squared minus b because of part 1. Because of part 1 above, I can replace that by a minus square root of b times a plus square root of b. Correct? This is the left-hand side, equals 0. Make sense? So again, I wanted to solve a squared equals b. A squared equals b is the same as saying a squared minus b equals 0 by subtracting b from both sides. And we just talked about a squared minus b in part 1. You see this expression, a squared minus b? It can be written as a minus square root of b times a plus square root of b. So this expression can be replaced by this product. Okay, and this expression was equal to 0, so this product should equal to 0. This is a product, right? All right, do you know when a product is 0? The zero factor property, right? The zero factor property, what is it? The zero factor property, it's right here. What does it say? A product is 0 if and only if at least one of the factors is 0. Back to the current problem. A product is 0 if and only if at least one of the factors is 0. So this means what by the zero factor property? So this means what by the zero factor property? So factor property, this means that either a minus square root of b, I think I changed colors here. Go back. So either a minus square root of b equals 0 or a plus square root of b equals 0, right? Which is equivalent to saying, so solve for a in each one. A minus something is 0. This means a is equal to the thing. So here I added by square root of b. Add square root of b both sides. You get a is equal to square root of b, right? Or How about now we subtract square root of b to solve for a here. You subtract by square root of b, you get a is equal to negative square root of b. Make sense? So we get this. So if you want to solve this one, a squared equals b, under the condition, remember, under the condition that b is non-negative, right? We are under this assumption. If you want to solve a squared equals b where b is non-negative, then that's the same thing as saying that a is plus square root of b or minus square root of b. You see this statement? That's equivalent to this. Makes sense? And as I mentioned before, you could have found this by the full power of the quadratic formula without this observation. And I encourage you to actually do it on your own. Okay? All right. I'm recording it here, right? This property that you see here is just the result that we just found. If you have two numbers a and b where b is non-negative, then the following are equivalent. They are equivalent. A squared equals b, this highlighted one, is equivalent to a is plus or minus square root of b, right? The same thing. All right, solve this. Let's take an example. Solve this equation. Well, this is of the form something squared equals something that's non-negative. Something squared that's equal to something that's non-negative. So I can employ that result. So this is by the previous property. So previous property. That's the same as saying, okay, maybe I should tell you with what, right? How about I tell you with what? Different color. So with a in the property to be played by 4x minus square root of 3, right? So that's the guy who's playing the role of a, and that's the guy who's gonna play the role of b, right? So and b is gonna be 3, right? So just to be clear. All right, so this is the same then as you see here. A is minus square root of b, so a, which is 4x minus square root of 3, is minus square root of b, and who's b? 3. Or, I'm copying, or a, who's a here? 4x minus square root of 3. So 4x minus square root of 3 is equal to square root of b. And what's b? Is 3, so square root of 3. Correct? One more time. Here I just used the previous result, this result that we just talked about over here. If a and b are two real numbers with b non-negative, remember b is 3 in my context, so certainly is non-negative. As such, you can use this result whenever you want. Well, I wanted it to be used when a is 4x minus square root of 3 and when b is 3, right? And as we said, b is non-negative, so I'm going to be able to use it. All right, so transitioning from this side to this side amounts to writing a is equal to, and a is 4x minus square root of 3. So a is equal to minus square root of b, and who's b? 3. Or the a, which is 4x minus square root of 3, is equal to square root of b, and who's b again? 3. So square root of 3. Now we want to solve for x, right? We want to solve for x. That's the same as saying 4x minus square root of 3 equals minus square root of 3. Let's add square root of 3 to both sides over here. If you add square root of 3 to both sides, it's going to disappear from here. So you get 4x. And remember what I'm doing? I'm adding square root of 3 to both sides. And it's going to disappear here as well. So I'm gonna get 0. Or over here, I'm gonna add square root of 3. Again, to make this disappear, I'm solving for x. I'm gonna get 4x equals, so I added square root of 3 here. I gotta add square root of 3 here to pick up an equivalent equation. And square root of 3 plus square root of 3 is 2 times square root of 3, right? Right, and image plus itself is twice the image. All right, let's keep going. So the situation is as follows. 4 times x is 0, so a product is 0 if and only if one of the factors is 0. So either the 4 who's 0 or x is 0. Well, x should be 0 because 4 is a non-zero constant. Or equivalently, you can just divide by 4, right? And lastly here, if you want to solve for x, you divide by 4 as well, and you get 2 square root of 3 over 4. And what's 2 square root of 3 over 4 if you simplify by 2? Isn't it square root of 3 over 2? So isn't it square root of 3 over 2? Makes sense? So what did we find? We found that if we replace x by 0, or if we replace x by square root of 3 over 2, we get that this guy, squaring that guy with the choice of x I just mentioned, is equal to 3. And this happens precisely when you choose such an x. It cannot happen in a different context. Okay, so what's the solution set then? So solution set is just 0 comma square root of 3 over 2. Okay, so let's go to the book and let's do this problem. This is on page 800, and the question is to find the solution set of this equation. Okay, all right, so it looks like, oh my god, what should I do here? Doesn't look like anything familiar. Well, what's the first thing we do when we want to solve an equation? We try to clean up the denominators, right? We try to clean up the denominators by multiplying by a suitable multiplicative constant, right? So I want to multiply this side and this side by a suitable entity so that I kind of clean up the denominators, so adding and subtracting would be an easier process, right? I don't have to deal with quotients anymore. What would be a nice product or a nice factor or something to multiply with the left-hand side and the right-hand side so that all the denominators clean up? Well, it should be a multiple of all denominators, which means it should be a multiple of x plus 3 and 4, right? So how about the product of the three factors then? So how about we multiply both sides by x times x plus 3 times 4? Okay, so if you do so, it's guaranteed to clean up all the denominators. Why? Because this thing that I'm choosing is a multiple of all three of them. All right, you're gonna see. So this is exactly the same as if we multiply by a common factor, so x times x plus 3 times 4. Okay, I'm multiplying by this, and if we do so, so I'm multiplying both sides by 4x times x plus 3. Okay, so I'm multiplying both sides by this 4x times x plus 3. And what did I have before? I had 1 over x plus 1 over x plus 3. I don't know why I crammed it. Since I have room, let me just erase it and rewrite it. So 1 over x plus 1 over x plus 3 equals to 1 over 4. this is what I used to have in the previous stage, and then I multiplied it by the green factor so that the denominator, all of the denominators are going to clean up. Okay, because each of the denominator is a divisor of this guy that I just introduced. In other words, this divisor that I just introduced is a multiple of all three of the denominators. So that's the same then as, so this factor is going to talk to 1 over x. So I'm going to get 4x times x plus 3 times the 1 over x. And it's going to also talk to 1 over x plus 3, right? I'm distributing. So that guy times 1 over x. And that guy times this entity. So plus this guy times the 1 over x plus 3, right? Is equal to this right-hand side. Let's keep it like this for the moment. And now, why did we introduce this green factor, the x time the 4x x plus 3? Because we wanted to clean up the denominators. All right, let's do so before we do anything else. So the 4 times x, this is a multiplication, times x plus 3 times 1 over x. So these x cancel out. So these x's cancel out. And I'm only left with 4 times x plus 3, right? I'm talking about the first expression. Plus, so see, the first expression, the new first expression is not anymore with the bad denominator. It used to have x downstairs. So now it's the denominator is 1, so it's all clean downstairs. Plus, how about this? I have the same factor as well, which is x plus 3 now. So x plus 3 is a common factor. You can cancel it out because, again, it's a multiplication here. So x plus 3 is a factor upstairs. Divide by this common factor upstairs and downstairs. We're done with this x plus 3 downstairs. So we have 4x times 1, so 4x, as promised, no denominator, equals, similarly, the 4 and the 4, right? The 4 and the 4. They cancel each other. So what are we left with? X times x plus 3. Makes sense? All right. This looks much better than the original equation, yet they are equivalent. They are the same. But this is a remodeling of that, which is closer to how which is easier to handle, let's say. All right, why it's easier to handle? Let's see why. How about we expand and simplify like terms? Okay, let's do this step. 4 times the entity x plus 3 is 4x plus 12, right? Plus this 4x equals x times x is x squared, and x times 3 is plus 3x, right? Okay. As we said, let's combine like terms and bring everybody to one side. The 4x plus 4x is 8x, right? So that's the same thing as saying 8x plus 12 is equal to x squared plus 3x. It's shaping up as a quadratic equation, right? It's shaping up as a quadratic equation. I see a polynomial of degree 2, you see? So let's combine like terms and bring all the terms to one side to put it in standard form. So you get 0. Let's move the 8x plus 12 to this side, which means I'm going to subtract by 8x plus 12, right? So subtract that, you get x squared plus 3 minus the 8 that came from the other side is minus 5x, right? And if we subtract it, we're subtracting by 12 here to get the 0. So we're going to subtract here as well by 12. Make sense? So that's the same thing as saying that x squared minus 5x plus minus 12 is equal to 0. Okay? I mean, this is the same thing. If 0 is this guy, then this guy is 0, right? Just swapped sides. So we get that. And I hope you see what I was alluding to. This is a quadratic equation. So that equation that we had, which looked very weird or unfamiliar, let's say, is technically something that we can handle. And we've been talking about this for a while now, right? So how can we solve this equation? I mean, now we are at a point which we are familiar, like something like this, right? What is it? Something like this, right? So this exercise that we talked about over here, correct? So a quadratic equation, one side is second degree polynomial equals 0, second degree polynomial equals 0, and so on. How did we handle it at the time? We factored the second degree polynomial by making the use of what we called previous exercise at the time. But in that exercise, what did we do? If you remember, we used quadratic formula to factor out the second degree polynomial. And once you factored out, the zero factor property kicks in, and we're done, right? So these are exactly the same steps I'm gonna take over here. So now I am at a stage where I've seen kind of before. I'm gonna involve the quadratic formula to factor the left-hand side. So we now use the quadratic formula with a to be, what's the coefficient? Remember a in the quadratic formula, it's the coefficient of x squared. What's the coefficient of x squared? Isn't it 1? And b, the coefficient of x with a plus sign in front. So this is going to be -5, right? -5. And the c is the constant part, which is -12. Correct? So I'm using quadratic formula to factor out the left-hand side. What's the b squared minus 4ac, the discriminant of the polynomial? B squared is -5 squared minus 4 times a, and what's a? 1, times c, which is -12 in our context. Yes? All right, so -5 squared is 25. The square of -5 is 25. Minus times the minus is plus, right? So plus 4 times 12 is 48. Okay. And what's 25 plus 48? This is 73, right? This is 50 plus 7 plus 23. Okay. Which is certainly non-negative. And as such, the quadratic formula, as promised, is going to be applicable, right? And what do we get? We need to find the m, and we need to find the m and the p, right? So m is -b minus the square root of b squared minus 4ac divided by twice a, okay? And what's that in our context? What's b? B is -5. So negative the b becomes +5 minus square root of our discriminant, which is 73. So square root of 73. 73 is a prime, right? So this guy is simplified. You cannot do much better than this. Divided by 2a. And what's 2a? What's a is 1. So 2a is 2. Okay. And the p is, the p of the quadratic formula formulated above is equal to, is very much close to that, but the only difference is the sign, the plus, right? So you get this. I mean, we talked about this above. So this sign, the minus sign, is actually plus for p. You get this plus, right? So now we know how to factor then. This was like a discussion on the side. in order for us to be able to factor what? To factor the left-hand side of this equation, right? So all of this here is actually needed to transition. And as such, I can factor the second degree polynomial existing on the left side by writing a. Remember, quadratic formula tells us a times x minus m, and m happens to be 5 minus square root of 73 over 2, times x minus the p, and the p is 5 plus square root of 73 over 2 equals 0, right? Equals 0. Okay, so a product is equal to 0 if and only if, by the zero factor property, one of the factors is 0. So now the zero factor property kicks in. So the zero factor property kicks in. Okay, and what do we obtain? We obtain that x minus this is 0 or x minus that is 0. So either x is going to be this guy, correct, the m, or it's going to be the p. So, or it's going to be the 5 plus square root of 73 over 2. Okay, so these are the two guys that were the solution of this equation, because this equation, as we discovered, is equivalent to this quadratic equation, which has these guys as solutions. As such, these are the solutions. let me just be here. Probably I skipped this step, and I should be clear about it. This question comes with a provision. Okay, it comes with a provision. What do I mean by this? Implicitly, they are telling you that this equation is meaningful, which means they're telling you that 1 over x makes sense and 1 over x plus 3 makes sense. So which means they're telling you that x should not be 0 and x should not be negative 3, right? This is the provision of the question, because if any of these two fails, then one of these quotients does not make sense, because one of the denominators would be 0. And as such, this equation is not meaningful anymore, and hence the question altogether doesn't make sense, right? So this is the provision that comes with the question. So this question is meaningful as long as x is not 0 and x is not negative 3, right? Because negative 3 makes this denominator 0. Makes sense? So, and in this context, we found our x's that we found, none of them is 0 or negative 3, right? So both of them are going to be actually solutions of my given problem. Make sense? So this quadratic equation and the initial equation are equivalent under this provision, okay? This equation and the second degree or the quadratic equation that we found along the way, they are equivalent as long as x is not 0 and x is not negative 3. Okay? And since the solutions that we found are, both of them are different than 0 and different than negative 3, then both of them are going to be the solutions of the given equation, right? Because as we said, this equation and this equation are the same as long as x is not negative 3 and x is not 0. And since this equation has these two guys as its solutions, then the initial equation is going to have those same guys as its solutions. Make sense? All right, so let's conclude. So therefore the solution set. So therefore the solution set, remember solution set means the set consisting of all the solutions, are those guys, 5 minus square root of 73 over 2 and 5 plus square root of 73 over 2. Okay. Hypothetically, let me just, I feel like I haven't explained enough the thing that I just made. So hypothetically, let's pretend that this guy is, again, let's pretend that this guy is 3 or negative 3. All right? Suppose that this happens. Well, this means that x is equal to negative 3 is a solution to this equation, right? This one. Well, but we said that this equation is equivalent to this. You're going to tell me then that x equals negative 3 is a solution of this. But what I'm saying is this equation and that second degree or this quadratic equations are the same as long as x is not 0 and x is not negative 3. Okay, so they are the same as long as this provision is verified. All right, which means this x, the x equals negative 3, which is a solution to this, cannot be a solution of that, because for such an x, these two are not the same. All right. All right, so this is what I meant with, I mean, we were lucky here we didn't have negative 3 as one of the solutions, nor 0, right? Otherwise, we should have thrown away the minus 3. Okay, all right. Finally, this question, 52. Write a quadratic equation that has the solution set minus 2 comma 6. So now they're giving us the final thing that used to be the final thing before, so the solution set, and now we want to find a quadratic equation. I emphasize over the article, indefinite article a, because you're going to see there are infinitely many equations or quadratic equations with such a solution set. So how can I come up with a quadratic equation with such a solution set? Well, if I give you an equation that looks like this, x plus 2 times x minus 6 equals 0. What's the solution set of this equation? Well, by the zero factor property, the solution set of this equation is, I mean, either x should be negative 2 or x is equal to 6, right? So that's the solution set then. So one more time. If I give you this equation, what's the solution set of this? By the zero factor property, one of the factors should be 0. So either x plus 2 is 0 or x minus 6 is 0, right? Which means x is minus 2 or x is 6. Make sense? So the solution of this equation that I just wrote are 2, negative 2 and 6. And hence the solution set would be exactly this. Make sense? So let me erase this part. So now you believe that this equation that I just wrote, this product equals 0, is or has this set as its solution set. Now, what do they want? They want quadratic equation, so they want a second degree polynomial equals 0. Right? This is the standard form of quadratic equation. So if you FOIL this out now, you're going to get a second degree polynomial, right? And as such, we answer the question. Let's do so. So let's FOIL this out. X times x is x squared. X times negative 6 is negative 6x. 2 times x is 2x. And 2 times negative 6 is negative 12, right? So we get this. And if you combine like terms here, you get x squared minus 4x minus 12 equals 0. Right? We used to be given this equation, and we used to solve such an equation. Makes sense? Which means we used to factor this left-hand side as such, and then use the zero factor property to get to the solution set. Over here, it's the backward direction. They're giving us what used to be the final thing, the set, the solution set, and they told us, give us a starting point. Give us a quadratic equation that has this set as a solution set. Okay? So we kind of like have to come up with a way to do so. I mean, one way is to force these two to be solutions. So x plus 2 times x minus 6 has these two as solutions, as we just discussed, and then FOIL it out. You get a quadratic or second degree polynomial equals 0, which means a quadratic equation, right? Okay. Now, why did I say here this indefinite article should be an indefinite article, not the? Because the quadratic equation can be, I mean, you have infinitely many quadratic equations that have the set as a solution set. To illustrate this, look, if I multiply here by 3, don't you still believe that the two solutions of this equation are still negative 2 and 6? I mean, 3 is not contributing to the product being 0. It remains that this guy should be 0 or this guy be 0, right? So I'm still talking about the same thing. And if you multiply this guy by 3, that's going to be also multiplied by 3. And that's going to be also multiplied by 3, right? Because the purple part is the same as this, So what do we get? We get 3x squared minus 12x minus 36 equals 0. This is another quadratic equation with this set as being the solution set. And you can do 5, right? You can do 8. You can do whatever number you want here. How many choices do you have for this number? You have infinitely many, right? You can choose whatever you want. You can take square root of 3 and so on, right? All right, let's stay with the simplest one. Which is the multiple is 1. That constant that you multiply with is 1. Okay, let's abstract this context. How about if the question is, write a quadratic equation that has the solution set. Instead of this, how about alpha and beta? Two numbers, okay? Don't worry about the names. Alpha and beta. So think about TS or whatever. All right, let's call the first one alpha and the second one beta. How can we get started to find this quadratic equation? Well, if you start with x minus alpha times x minus beta equals 0, by the zero factor property, the solutions of this equation are simply alpha and beta. So these guys, right? And then if you FOIL it out, I'm going to put dot, dot, dot here. If you FOIL it, you're going to see that x times x is going to be x squared. So if you FOIL it, you're going to get the quadratic equation. So you're going to get quadratic equation at the end of the day. And this quadratic equation is going to be equivalent to this one, which has this as a solution set. And as such, we are providing ourselves with a quadratic equation that has this as a solution set. Okay, so no matter what these numbers are, we can just put them here as we did here over here, right? I mean, look, alpha was negative 2. So what's x minus the alpha? Alpha is negative 2. This becomes x minus the minus 2. X minus the minus 2 is x plus 2. It's right there. And beta was 6 at the time, right? So x minus 6, it's right there. So with this special alpha, this special beta, we were able to write this or start from this equation and FOIL it out to get the quadratic equation or a quadratic equation that we wanted. Right? So in general, if alpha is some abstract number and beta is some abstract number, we would start from this. And you can multiply it by any number you wish here, as we discussed, right? 3, 4, whatever. And FOIL it out, get a quadratic equation, and it's guaranteed, because they are equivalent, guaranteed to have this set as a solution, as its solution. All right. So this ends this section.